Hello, everyone. Today, I'm going to walk you through the final evaluation of my machine learning pipeline for predicting credit and card defaults. In credit lending, building a model with a high ROC AUC curve is only half the battle because we are dealing with a heavily imbalanced dataset where 92% of examples are negative. And because this is a massive human cost to algorithmic errors, a purely mathematical approach is not enough. Today, I'll explain how I ensure this model adheres strictly to responsible AI principles, focusing on model interpretability and demographic fairness. And I will start with interpretability. To access exactly how our XGBoost model was making its predictions, I implemented SHAP, or using a tree explainer. This was not just a final report step. It was just critical to diagnostic tool. During my initial modeling, the SHAP summary plot revealed a severe data leakage issue. The model was relying heavily on the ID feature. In other words, the algorithm wasn't learning financial risk. It was just memorizing specific customer ID numbers. Because I used SHAP to interpret the fit, I was able to catch this flaw, drop the ID column, and completely retain the pipeline. As you can see on the screen now, the correct model logically anchors its decision on high valid explainable financial indicators, especially external credit score and client age. This level of transparency directly support ethical decision making, ensuring that if a client is denied credit, we can provide a concrete behavioral reason rather than just a black box excuse. However, um, just because a model is transparent does not automatically make it fair. To ensure our pipeline strictly adheres to the RAI principles, I actively audited the final model for demographic bias using the FAIR-LEARN library. I tested the model against the protective sensitive attribute gender. We evaluate two rigorous fairness metrics to ensure the model wasn't quietly discriminating. First, our demographic parity difference came in exceptional 0.0028 of a difference. This proves that it's virtually non-systematically biased in our overall approval and deny rates between men and women. Second, we test the equalized odds difference, which looks at the model's mistakes rate, specifically false positive and false negatives. Our model scored 0.045. Falling comfortably between the strictly 5% industry threshold means that our model does not make an error. It distributes those errors fairly and does not unfairly burden one demographic over other. In conclusion, by combining XGBoost's predictive power to handle our dataset's severe class imbalance, using SHAP to force arithmetic transparency, and validating our output for FAIR-LEARN, we have built a credit default model that is not only highly accurate but ethically sound. It balances the strict business requirement of risk management and the critical ethical responsibilities of modern responsible AI. Thank you.